Okay, continuing on our journey, let's talk about something called the remainder theorem. And surprisingly enough, the remainder theorem is all going to be encompassed with this stuff that we did on the previous podcast. It's all going to be part of learning how to graph these things. It's really, really fascinating at this point. Okay, so what does remainder theorem mean? Remainder means just like remainder. You know, and I know if you try to divide 3 into 10, you know it's going to go 3 times. That makes a 9. You got a 1. That's your remainder. Oh, so does that mean I can do the same thing with polynomials? You betcha. Check it out. Look, here's my one polynomial. I'm going to divide each one of them by 5x. So think about it. If you want, you can take this 5x and go, okay, we'll rewrite this one. We'll rewrite it with this. We'll rewrite it with this. Every one of the top terms has to be divided by the 5x. And if you look at this, this becomes a math 10 thing. I mean, 15 divided by 5, that's too easy. That's 3. X cubed divided by x, that's x squared. Minus 10 divided by 5 is 2. X squared divided by x, that's x. And finally, 5x over 5x, please don't tell me that that's 0. That's actually 1. All right, so what we say then, there's some technical words here that you gotta remember. The dividend is the thing that you initially divide. The divisor is the thing that does the dividing. And then, of course, your result, which we call the quotient, is our answer. Okay, if we have a remainder left over, we call it a remainder. That's just way too easy. Oh my goodness. Okay, so let's go on. Look, use long division to divide this guy out. Okay, easy peasy. 13 goes into 2, 7, 4, 8. Check it out, baby. 13 goes into 27, that goes into twice. That gives you 26. Subtract it out, that's 1, 4, and 8, of course, right? 13 goes into 14 once, giving you a 13 here. Subtract again, gives you an 18. That 13 goes into 18 one more time. That gives you 13 with a remainder of 5. So think about this for a second here. When you were talking about long division, in this case, the dividend is our 27/48. The divisor is the thing that you're dividing by. That's 13. The quotient then is 211, your answer. And the remainder in this case is going to be 5. Wow. So what's really cool here is we're going to eventually start looking at something called division statements. And there's 2 different kinds of division statements that we're going to make here. The first division statement is very, very simple. It's going to say that original polynomial. Do you remember the original polynomial up here? Okay, or even this particular number. The original one was 2748. That equals to, Dairy Queen, DQ, let's go for a blizzard, man. No, not that at all. Division, or the divisor, or the dividend, and the quotient. Okay, so the divisor here being 13. The quotient being 211, plus the remainder of 5. Think about this. If you multiply 13 by 211, you're going to get 2743. Plus the remainder of 5 gives you your original value of 2748. Yeah, that's one way of writing it. The other one is you can write it this way. Dividend divided by divisor. Dividend being 2748 divided by the divisor, which is 13. So that's, in essence, that's kind of looking like fractions, isn't it? That kind of looks like fractions. Gives you your quotient being 211 plus whatever is remaining. What's remaining is 5 out of the 13 that's remaining. There you go. That's how you do those kinds of division statements. So can you actually divide out polynomials? I mean, we can divide out numbers. We've been doing that since like grade 3, right? Can we actually divide out polynomials? Yes. The same process of division can be used to divide a polynomial. What do you mean by that? Well, let me show you. Here's example 1. I've got another example, but I'm going to put that onto the other podcast so it doesn't make this podcast too long. But check this out. I've got a beautiful polynomial sitting right here. This is what I'm going to divide it by. There's our divisor. So I'm going to take x minus 1. There it is. I'm going to divide this into, check this out, 2x cubed minus x squared minus 2x plus 1. You see it? Simple. Okay, now, is there a special rule that goes along with this? Yes, there is. Take a look at just this x. Now remember, you want to be able to subtract out the x. You want to start getting rid of these terms as we go. Okay? And the way you do this, if you remember correctly, is strictly by subtracting them out, right? So what you're going to try to do here is you're going to try to make this guy match this guy. Well, that's easy because that's 2x cubed. So what times x, and like I said, just look at the first one, what times x gives me 2x cubed? Well, think about it. Isn't that 2x squared? Well, sure it does. Now, watch what we do. 2x squared, distribute, gives you 2x cubed minus 2x squared. Oh, well, let's deal with this. Just like you did in long division with numbers, you would subtract this. But remember, you're subtracting the whole thing. So look how this 2x cubed and 2x cubed cancel. That's why I picked this number, so that those guys actually cancel out. Ah, I see now. But don't forget, that minus is also distributed to here, making this a plus. So you got a minus x squared plus 2x squared gives you got it, x squared. Bring down the minus 2x. Okay, so now you're back to the same thing you had before. What times this x will give you an x squared? Yeah, you got it, x. X times x minus 1. Distribute. Look at this. You're going to have an x squared minus x. Subtract. And the whole idea then is always to see if you can eliminate that first one. But here's where a lot of students get caught. You forgot to distribute this. This becomes a plus x. So minus 2x plus x is actually minus x. Bring this guy down, plus 1. Okay, not finished yet. What times x gives me a minus x? Yeah, you got it, minus 1. Watch this. Distribute, gives you a minus x, distribute, plus 1, right? Plus 1. Subtract this out. Okay? If you subtract this out, watch this. Put a minus here. That, of course, cancels with this. But again, this is distributed, so this is plus 1 minus 1, which gives you a 0. You have no remainder. But what's your answer for something like this? Your answer is right here. All the values that you multiplied by. Your answer is 2x squared plus x minus 1. There's your answer. Wow. Cool question, hey? Okay, so my suggestion at this point is back this podcast up, watch how I do it, because the next question I'm going to do, it's got a lot more detail to it. So make sure you know how to master this question before we go into the next question, okay? All right.